So now we get into the nitty-gritty of what the Metabolight project is all about, and that is looking at how light interacts with the brains of babies. So as Gemma mentioned, light travels through our bones, so in this case it'd be the skull, and it will show us the oxygen levels of the blood within our brain.
Exactly. So the reason we can do this is because blood changes colour depending on whether it's carrying oxygen. So you probably already knew that blood is really bright red when it's oxygenated and more of a purple colour when it's not. And that's all because it changes its absorption spectrum when it's carrying oxygen. So we can use what we've learnt about absorption spectrum in the previous chapter and have a look at the absorption spectrum of blood, both oxygenated and deoxygenated. Then the pupils can have a look at that and try and figure out what colour blood is when it's oxygenated and what colour it is when it's deoxygenated. So this is really important because oxygen is obviously a really important molecule in the body. It's used in respiration to produce energy. And so in a medical context, doctors need to know if oxygen is getting to all of the parts of the body and making sure the patient's healthy. So on page 14, we have an activity where we get them to calculate the different levels of oxygen in 2 case studies and link those oxygen levels to health.
So a lot of students might be familiar with checking their heart rate by feeling the beat of the pulse in their neck or in their wrist. But we're showing another way in which they can check their heart rate is using light and a pulse oximeter, in which some schools might actually have.
So the way a pulse oximeter works is it shines light through the finger, just like we were doing with our torch. So if you have one of these, you can see inside the pulse oximeter there's a flashing red light. And this is actually flashing a red wavelength and an infrared wavelength, which both travel really well through the finger. So if I put my finger on there, you can see that the light travels through. And on the other side, there's a detector, which is measuring how the light changes as it goes through my finger. And every time there's a pulse of blood, there will be more light absorbed by the body. And so the pulse oximeter is able to count the heartbeats by looking at the variation in light through my finger.
We've then included a nice task which asks pupils to plot some data taken from a pulse oximeter and then use this to spot patterns and then hopefully measure a patient's heart rate per minute. So as a final investigative task, we ask students to measure their pulse while sitting and then see what happens to that after they've done some exercise such as doing star jumps.
And if you don't have a pulse oximeter, you can use your phone and download an app to act as a pulse oximeter. So, for example, I have an Android phone and I've downloaded the Accurate Heart Rate Monitor, but on an iPhone...
You've got the Cardio Heart Rate Monitor.
And the way these apps work is they use the torch in the phone to shine light into the body, and then they have the camera of the phone detecting the light that comes back out. And then just the same as the pulse oximeter, as the light changes because of the pulse in the body, the phone app is able to record that. So you can see on Yasmin's phone, as her heart rate is changing, it changes the amount of light detected, and then they can calculate the pulse rate. So this is an example of showing the pupils how, just by using light, we can find out something about the body.
And to download a copy of the Lightsaver resource, including the teacher guide, student guide, and the case studies, you'll find all of this on the Royal Academy of Engineering STEM Resource Hub. In addition to links to UCL Engineering and to the Metabolight project.